Hi, welcome to my channel, Math Made Easy with Laurel. I'm Laurel, and in this video we're going to take a look at the multiplication rule of probability with dependent events, also called conditional probability. In my last video we talked about the multiplication rule with independent events, and in this video we're going to take a look at dependent events. So first, a definition. Conditional probability is defined as the likelihood of an event or outcome occurring based on the occurrence of a previous event or outcome. Conditional probability is calculated by multiplying the probability of the preceding event by the updated probability of the conditional event. It might sound a little bit confusing, but we're going to go through a number of examples that will hopefully clarify what this definition means. Just a quick review of independent events. If two events A and B are independent, which means the outcome of one does not affect the outcome of the other, then the probability of A and B will be calculated by taking the probability of A times the probability of B. Just a quick example. If you choose one card from a deck, put it back and choose another card, what's the probability that both cards are hearts? Whatever you chose the first time is not going to affect the probability of what you choose the second time. So the probability of choosing a heart and a heart would be the probability of choosing a heart, which is 13 out of 52. There's 13 hearts in a deck of cards, 52 cards. Because we replace it, there's still 52 cards that we choose when we choose the second card. So the probability again will be 13 over 52. So our probability is 1/4 times 1/4, or 1/16. That's for independent events. Dependent events would be different. So for example, if you did not replace that first card, that's going to change the probability of choosing a heart on your second draw. So let's take a look at the formula for dependent events and look at that specific example. If two events A and B are dependent, in other words, one event depends on the other, then the way that you're going to calculate the probability of both things happening, so the probability of A and B, is you take the probability of A and you multiply it by the probability of B given A. Let's take a look at the card example and show what we mean by this probability here. This time we're going to choose two cards from a deck. So we're not replacing one, we're going to choose one and then choose another without replacing the first one. What is the probability that both cards are hearts? I think the best way to illustrate this is with a tree diagram. And in this case, we're looking for an outcome of a card being a heart. So if we choose and the card is a heart, the other option is that it's not a heart. So what's the probability for choosing a heart? There are 13 hearts in a deck of 52 cards, and there are 39 cards that are not hearts in a deck of 52. Then when we choose our second card, if our first card is a heart, again, the two options are we choose another heart or a card that's not a heart. So if we choose a heart on our first draw, now there are only 12 hearts left in the deck and there's only 51 cards left. If we choose a heart on the first card, then there are still 39 cards that are not hearts, but only 51 cards that we're choosing from. Now we're really interested just in this part, choosing two hearts, but I'm going to complete the tree diagram. If our first card was not a heart, then there are still 13 hearts in the deck, but we only have 51 cards to choose from. If we chose a card that was not a heart, now there's only 38 cards that are not hearts out of 51. So that's our tree diagram. And this is, if we look at our formula, what's the probability of choosing a heart and a heart? Well, we take the probability of choosing a heart will be 13 over 52, or 1/4. And then we take the probability of choosing another heart given that we chose the first card was a heart. So the probability of B given A is this probability here, 12 over 51. So the probability of choosing 2 hearts will be equal to 1/4 times 12 over 51. 4 goes into there once, there 3 times. 3 goes into there once, 17. So that probability will be 1 over 17. That's different than the probability of choosing 2 hearts when there was replacement, when you had independent events. Let's take a look at some more examples. So our next example says you have 3 red and 5 green candies in a bag. Choose 2 candies without replacement. So that means you don't choose one candy and put it back before choosing a second candy. You take one out, you don't replace it, then you choose the second candy. What is the probability of choosing 2 red candies? Because we're not replacing the first candy, these 2 events are dependent. What we choose for the first candy will affect the probability of what we choose for the second candy. The question says, what is the probability of choosing 2 red candies? I'm going to draw a tree diagram because I think it makes it easier to understand. And also I'm going to ask a few different probabilities with this particular example. When I choose my first candy, it's either going to be red or it's going to be green. Then after I chose the first candy, I choose again, and it's either going to be red or green. So these are all of the possible outcomes. Let's attach probabilities to those outcomes. So what's the probability of choosing a red out of all of these candies? Well, there's 3 reds out of a total of 8. So the probability of choosing a red candy is 3/8. Similarly, there's a probability of 5/8 for choosing a green candy. Now we look at what happens to the probability of choosing a red if we chose a red on our first candy. So if we chose a red on our first candy, now there's only 2 reds, but there's still 5 greens. So the probability of choosing another red would be 2 out of 7. The probability of choosing a green will be 5 out of 7. On the other hand, if our first choice of candies was green, we're now left with 4 green and 3 reds. So the probability of choosing a red on the second draw would be 3 out of 7. And the probability of choosing a green for the second candy would be 4 out of 7. Now, we're asking what is the probability of choosing 2 reds? So that means a red on the first candy and a red on the second candy. So in this case, the probability of choosing a red candy on our first choice is 3/8. And then the probability of choosing a red candy on the second choice, given that we chose a red candy on the first, is 2/7. So the probability of choosing 2 red candies will be equal to 3/8 times 2/7. 2 cancels, and we have 3 over 28 as our probability. Let's now take a look at another question. What is the probability of choosing 2 green candies? So 2 green candies means a green on the first and a green on the second. So what's the probability of choosing a green on the first? Probability of A is 5/8. What's the probability of choosing green for the second candy? Given we choose green for the first candy, that's 4/7. So our probability of choosing 2 greens would be 5/8 times 4/7. Let's just cancel the 4. So that probability would be 5 over 14. Our next example says that Ted works at McDonald's. His favorite job is working the drive-through window. With boss Sue, the probability of Ted working the window is 0.5. With boss Jim, the probability of Ted working the window is 0.3. Sue is boss more often than Jim, about 6 out of every 10 shifts. What's the probability that Ted will work the window on any particular day? in order to make our tree diagram, we have to decide what the first part of the tree is. Well, whether he works the window or not, first of all, depends on who's boss. So we start there. Sue or Jim, those are our two options. What's the probability that Sue will be working? Well, if she works 6 out of every 10 shifts, that's 6/10 or 0.6, which means Jim works 4 out of every 10 shifts or 0.4. Then, if Sue is boss, what is the probability that Ted will get to work the window? It's 0.5. So it means a 50% chance that he won't work the window. If Jim is boss, the probability that Ted will work the window is only 0.3, and the probability that he won't is 0.7. So the question asks, what's the probability that Ted will work the window on any particular day? This is an example of the addition rule of probability as well as the multiplication rule, because we have two ways that Ted can work the window, either when Sue's boss or when Jim is boss. So when it can happen two different ways, one way or another, we add those probabilities. So in this case, the probability that Ted works the window will be 0.6 times 0.5 if Sue's working, plus the probability if Jim is working will only be 0.4 times 0.3. This part of the equation is our multiplication rule. This is the probability that Sue's working, and then this is the probability that Ted will work the window if Sue is working. Similarly, this is the other way that Ted could work the window. The probability that Jim is the boss times the probability that he would work the window given Jim is the boss. And he can work the window either this way or this way, so we add the two. Now we'll calculate it. 0.6 times 0.5 is 0.3. 0.4 times 0.3 is 0.12. So 0.42 or 42% probability that Ted will work the window when he goes into work. This next example is a little bit different, but we're going to still use our conditional probability formula. The question says 70% of your friends like chocolate ice cream and 35% like chocolate and strawberry ice cream. What percent of those who like chocolate also like strawberry? So let's figure out what probabilities we know. The probability of a friend liking chocolate ice cream is 0.7. The probability of a friend liking chocolate and strawberry is 0.35. The question says what percent of those who like chocolate, so given they like chocolate, what percent also like strawberry? So that's a conditional probability. What's the probability of someone liking strawberry given they like chocolate? So let's just review our formula. The probability of chocolate and strawberry will be the probability of chocolate times the probability of strawberry given chocolate. In this case, we know this. We know this, and we're finding this. So the probability that they like chocolate and strawberry divided by the probability they like chocolate will equal the probability that they like strawberry given they like chocolate. Now we can plug our numbers in. 0.35 over 0.7 will equal this probability, and that's equal to 0.5. So it gets a little more challenging with the words, trying to determine what probabilities you know, as well as what probability formula you're going to use. Let's do one more example that brings in the addition rule as well as the multiplication rule. The last question says the probability that Annie enrolls in a certain class is 0.3. The probability that Barb enrolls in the class is 0.6. And the probability that Annie will enroll given Barb enrolls is 0.4. We have two questions. We want to know the probability that Annie and Barb enroll, and we want to know the probability that Annie or Barb enroll. Let's start off by listing what probabilities we know. We know the probability of Annie enrolling. We know the probability of Barb enrolling. And we know the probability of Annie enrolling given Barb enrolls is 0.4. So when we find the probability of Annie and Barb enrolling, it's going to be the probability of, so Annie's probability is based on Barb's, so we give probability of Barb enrolling times the probability of Annie given Barb. So the probability of Barb enrolling is 0.6. Probability of Annie given Barb is 0.4. So the probability of Annie and Barb enrolling is 0.24. The next part of the question says, what's the probability that Annie or Barb enrolls? And I discussed the addition rule a few videos ago. The way that we're going to find this, the probability that Annie or Barb, so that symbol means or, will equal the probability of Annie plus the probability of Barb enrolling minus the probability of Annie and Barb. So in this case, we've got the probability of Annie enrolling as 0.3 plus the probability of Barb enrolling, which is 0.6, minus the probability of Annie and Barb, which is 0.24. So that's equal to 0.66. So the probability that Annie or Barb enroll is 0.66. So these probability questions can be challenging because they might involve the multiplication rule or the addition rule or some of the other rules that we talked about with probability. The key is understanding what the words mean and how to interpret those into probabilities.